The paper of the day is the Volcano Optimizer Generator, Extensibility and Efficient Search. The query optimizer's job is to take user input in the form of SQL and generate a cost-efficient plan for satisfying that query using the underlying physical layout of the database. This paper describes Volcano, a system for taking a data model, logic algebra, physical algebra, and optimization rules and translating them into optimizer source code. At a high level, Volcano provides a framework for database implementers to input a model specifying the properties of the physical and logical model. For each user query, the database implementer passes the query to the Volcano Optimizer Generator, and Volcano outputs an optimized plan for that query. First, Volcano allows for an extensible algebraic and logical set of operators that describe the operations of the underlying database in terms of equivalence relationships, set operations on the data, and suitable implementation algorithms. Volcano's job is to map an expression in the logical algebra into an expression in the physical algebra, where the logical algebra describes a user's query and the physical algebra describes a query plan of algorithms that satisfy the query. Continuing the Volcano design principles. Second, Volcano uses the concept of rules to allow database implementers to describe general algebraic relationships and patterns that can be applied to a query. Third, any choices that the generated optimizer is allowed to make must map a query into the optimal equivalent evaluation plan represented as logical and physical algebraic equivalences. This is in contrast to some optimizers that generate a sequence of intermediate steps between a user's query and an optimized query plan. Fourth, Volcano made the choice to generate compiled code rather than code that may be interpreted. Fifth and finally, the search engine uses dynamic programming by retaining a last set of partially evaluated results and using these results in later decisions. In effect, Volcano uses a backward chaining to search through a decision tree for the most optimal query plan according to the logical and physical algebra provided by the database implementer. Improvements over Exodus prototype. First, the new optimizer generator had to be usable both in the Volcano project with an existing query execution software as well as in other projects as a standalone tool. Second, the new system had to be more efficient both in optimization time and in memory consumption for the search. Third, it had to provide effective, efficient, and extensible support for physical properties such as sort order and compression status. Fourth, it had to permit the use of heuristics and data model semantics to guide the search and to prune futile parts of search space. Finally, it had to support flexible cost models that permit generating dynamic plans for incompletely specified queries. Volcano in database. To use Volcano in a database, the implementer provides a set of logical operators, algebraic transformation rules, a set of algorithms implementing rules for those algorithms, a cost function for arithmetic and comparison functions, logical properties describing the database schema, physical properties describing algorithmic dependencies such as sort, ordering, and partitioning, and an apply function for each algorithm and a cost function for each algorithm. Volcano takes this data and creates an optimized query plan for user input. Although this seems like a lot of code for the database implementer to provide, it is argued in the paper that is still a total work saving for the database implementer when considering the alternative of providing all of these rules and implementing the search algorithm that Volcano provides.